Hi! In this video, we will talk about the hardware design guidelines for BGM121 and BGM123 system-in-package modules. We will start by discussing about the module's power supply scheme, followed by a walkthrough of a reference schematics design and the PCB Layout Guidelines. We then finalize with a brief discussion about the effect of different materials on the BGM121 and 123 antenna performance. The BGM121 and 123 have a flexible power supply scheme with efficiently integrated regulators to generate internal power supply voltages. Only a single external supply voltage is required, VBAT, from which all the internal voltages are created. An integrated DC-DC buck regulator is utilized to further reduce the current consumption. VBAT supplies directly the analog block and the DC-DC regulator. The output of the DC-DC will then supply the digital, RF, and RF power amplifier blocks. Additionally, the I/O pin interfaces can be referenced to a voltage other than VBAT through the I/O VDD reference, as long as that reference is below VBAT level. If this is not required, then it should be connected to the same voltage level as VBAT. Let's now walk through a simple reference schematic design and highlight the main aspects to take into consideration when making your BGM121 and 123 design. All ground pins must be connected to solid ground, as well as the antenna ground pin. It is highly recommended to expose the debug interface in your system, which is available through pins PF0 to PF3. The reset pin is also required for the debugger, and in case that you are using a host to control the BGM121 and 123, then it is recommended to connect the reset line to the host device as well. Pins 2G-RF and in and 2G-RF port must be connected together in order to use the antenna integrated into the BGM121 and 123. The connection between these two pins should be made as short as possible to avoid introducing any parasitic elements to the antenna path. Routing this connection through vias and different layers of the PCB is highly discouraged, as the parasitic elements will detune the antenna and affect its performance. If an external antenna is meant to be used, then it should be connected to 2G-RF port pin, and 2G-RF and in can be left unconnected. If your design is meant to support both options of using the integrated antenna or an external antenna, it is recommended to use 0 ohm 0201 package resistors on the selected antenna path to introduce the least possible parasitic capacitance. The crystal pins HFXO out and HFXO in must also be connected together with the shortest possible trace. We will now discuss the PCB Layout Guidelines for the BGM121 and 123 when using the integrated antenna. The module must be placed at the edge of the PCB as shown in this figure, and never in a central location, which will result in severely degraded RF performance. A copper clearance area must be created on the module's PCB layer, as well as at the bottom or any of the middle layers if existing. On the top layer, the clearance area measures 2.2 by 5 mm, and in addition, there must be also copper clearance in between the antenna ground pad and the adjacent power ground pad. On the bottom or middle layers, the clearance area measures 3 by 5 mm. It is extremely important to follow the clearance area measurements given in the BGM121 and 123 datasheets, as the ground plane portion around the clearance area forms the antenna loop, which is crucial for the antenna's performance. The ground pads should be connected directly to a solid ground plane, and the ground vias should be placed as close as possible to the ground pads, or even underneath. For vias underneath the pads, you should use micro vias if you have an HDI PCB, or plugged through-hole vias on standard PCB, so that the solder doesn't cross to the other side of the via. The ground pins around the copper clearance area should not be connected to the ground plane using thermals in order to avoid introducing impedance in the antenna loop area. Lastly, it is recommended the extensive use of ground stitching vias, especially along the edge of the board and around the copper clearance area, to stitch overlapping ground planes. For optimal antenna efficiency, there should be a ground plane around the module with an edge-to-edge width of 44 mm. The module should be placed at the center of this ground plane, and it is allowed to have components in the ground plane area. Please note that the left side scale indicates how many dBs are lost compared to the selected max TX power. Taking a practical example, if you configure the module for +8 dBm and your ground plane width is 30 mm, then the effective TX power will be 5 dBm. The length of the ground plane doesn't have an impact on the antenna performance, and it can be as short as the length of the module itself, plus any additional space for routing. If you are using an external antenna, then you are free to place the module anywhere in your board, and the ground plane width no longer has an influence in the antenna performance. The copper clearance area is also not required, and you can connect all the ground pads to the ground plane using thermals. The ground stitching vias should still be used, as that is generally a good layout practice. For connecting the external antenna to the 2G RF port pin, you must use a 50 ohm trace and keep it as short as possible. The antenna on the BGM121 and 123 is insensitive to the effects of nearby plastic and other materials with low dielectric constant. No separation is needed between the module and such materials, and this includes conformal coating, which can be applied directly on the module. The antenna on the BGM121 and 123 will be affected by nearby metal materials, and a separation of 10 mm is recommended between the module and the metal materials. Placing the module in touch or very close to the human body will negatively impact the antenna efficiency and reduce range due to its high water content and conductive properties. We hope you have enjoyed this video on how to make your hardware design based on the BGM121 and 123 system and package module. Make sure to watch the next BGM121 and 123 video to learn more about the antenna performance and robustness. Thanks for watching.